Sylest. I'm so sorry to just get your email now. It's been a crazy 24-hour period. But I think I can help you out with this. I'm going to pull the problem up here real quick so I can look at it while we're working. Okay, here it is. And I think I understand the situation. There's 50 balloons. You pay $2 and you get to pick 2 balloons. Okay, so we're going to have... I know you're in 105, and I know you've done tree diagrams for a while now. We're going to do that, but not... I guess kind of the way that one's set up right there. So you're starting out here, and then you're going to pick the first balloon. That's now the French spell balloon. Let's spell ballon. Okay, so either it has a prize or it doesn't. Prize, no prize. Okay, now if I remember correctly, 21 have prize tokens. So the chance of you getting a prize on the first balloon is 21 out of 50. I'm going to put that in a little circle here. Which means the chance of not getting a prize on that first one is whatever's left out of 50. 29 out of 50. So now you've taken one of the balloons down from the wall, which means there are now 49 left for you to pick to get your second balloon. Spell balloon like a French person again. Now here's the deal. There's tons of prizes on the board, and there's also tons of non-prizes on the board. So whatever happened on the first balloon, whether you picked one or didn't, you're still going to be able to either pick a prize or not pick a prize. I'm using terrible notation. I should use the notation that's in your homework here, or your project here. They're using token and NT. So T for token. I should be using the same damn thing. T, token, means you got something. No token. NT means you didn't. Let's use that same language here. Sorry. So token, no token. Same thing down here. You could either get a token or you could not get a token. Now, let's work through this together. Here, you got one of the tokens. That means there used to be 21 balloons out of the 50 that had tokens. The chance of getting another token just went down a little bit. First of all, it's only out of 49 because you took one of the balloons away. And you also took one of the balloons away that has a token in it. So there are no longer 21 winning balloons, there are only 20 winning balloons. And hopefully that makes sense. Now, that could happen. I mean, clearly you could get a token on both of them. You could also get a token on the first one and not get a token on the second one. Now, what's the chance of that happening? Well, there's still only 49 balloons left on the board. And you have to remember back, if 21 of the original balloons had tokens in them, that means 29 didn't. And all of those losing balloons are still on the board. So the chance is going to be 29 out of 49. You might notice that these two things add up to 100%, just like these two things add up to 100%. They have to, because one of these two things is going to happen in each one of these little sets of branches. One of those two things is going to happen. Here, you chose wrong first. You got one of the non-token ones. That doesn't mean you're going to get a non-token 1 second. You could get a token 1 second. And there are still 49 of them left. Remember, you took this one off the wall, which means there are still 49 balloons left. However, you grabbed one of the ones without a token in it. There are 21 have a token in it. All those 21 are still on the wall. That means your chance of getting a token here is actually a little bit higher than your chance of getting a token here. But it's also possible, completely possible, that you drew a non-token balloon here and you also draw a non-token balloon here. Now, what's the chance of that happening? Well, it's still out of 49. You pulled one of the 29 losing balloons. That means there's only 28 of them left. And once again, you can check these two fractions and make sure they add up to 100%, which they do, 49 out of 49. Now, here's where you have to get the probabilities from. I'm looking at this table at the bottom here, and it says number of tokens. So let's look through here and see these. There's 4 branches. If you start here, you can either get a token here and a token here. That's 2 tokens. That's the bottom part of the chart down there. You could get a token here and not get a token here. That's the 1 token scenario. That's the middle. You can not get a token here and get a token here. That's also 1 token. You got it on the second balloon. Or you can not get a token and not get a token. And that's the 0 tokens. That's the top part. So there's 4 branches on this tree. 2 of them go in the middle, the 1 token. 1 of them goes in the 0 tokens. 1 of them goes in the 2 tokens. Now here's where we have to call on your old math that I'm assuming you've done already in Math 105. We have to figure out the chance of both of all of those things happening, because there's going to be 4 probabilities. There's a little bit of space. You can see that we set up the tree kind of like in your project up there, so you can actually recopy this directly into your project. There's one more thing you need to have, and I haven't left a whole lot of space for it, to the right of this, which is what's the chance both of these things happen? What's the chance both of these things happen? What's the chance both of these things happen? And what's the chance both of these things happen? And this is where we're going to call back on what you already done in Math 105. You're going to multiply the probabilities together. So this one here, I'm going to write really small. I hope you can see it okay. Is 21 over 50 times 20 over 49. That's just 21 times 20 over 50 times 49. And you can just run that through a calculator and figure out what that's equal to. I'm guessing it's going to be about 16%, but I'm doing that in my head. Check the math on me there. What if you get a token first and not get a token second? Well, that's going to be 21 times 29 over 50 times 49. As a matter of fact, all of these probabilities are going to have a denominator of 50 times 49 because you're drawing a balloon, then drawing a second balloon from the wall that has 1 less balloon on it. So the only thing changing really is the numerator. This one's going to be the same as the one we just did, except the numbers are in the reverse order. 29 times 21 over 50 times 49. So whatever you got here, you're also going to get here. The math is the same, which hopefully makes sense. You're getting 1 loser and 1 winner. And last but not least, it looks like the most likely outcome is going to be this one. 29 times 28 over 50 times 49. Okay. Now, to help you fill out this chart a little bit, I'm going to send this video to you so you can work on it quicker than later. It's got the number of tokens 0, 1, 2. You have to fill in the probabilities for each of those 3 things. Now, the 0 tokens one is right here. No token, no token. This right here is the chance of no tokens at all. That's the chance you don't get any prizes whatsoever. I'm going to jump over the middle one for a second and go to the end. The 2 tokens. What's the chance you get 2 tokens? That's right here. 21 times 20 over 50 times 49. The chance of 1 token is these 2 added together. So figure out what that one is, and it's the same for this one, so you can just multiply this one times 2 if you want to, and you'll get the exact same number. These 4 things have to add to 100%, so another way you can do it is, once you figure this one and this one out, you can take it away from 100%, and that's going to be what's left here. But yeah, these 2 probabilities equal, those 2 added together equal that middle probability. One more thing to think about here, and she's actually gave you a column here for the value. The payout is 0, 2, and 5. And then she put this little value column next to it, which is take the $2 that you had to pay to play out. So 0 minus 2 is going to be negative 2. 2 minus 2 is going to be 0. And 5 minus 2 is going to be 3. So if you lose, you don't actually you don't actually win $0. You actually lose $2 because you had to pay to play. If you win $2, you actually don't. You actually broke even because you paid $2 to play and then you win the $2 back. The only one of these three things that you actually win on any positive amount of money is that last one, because you paid $2 to play. If you win with the 2 tokens, you get $5 back, which means you've really profited $3. That's the next column. And then the expected value for each row, the key here is you're going to take each probability in column 2 and multiply it by each of the values in column 4. And that's going to be the three cells to the right there. And then the total expected value is just those 3 things added together. I'm hoping that because this is a project on expected value, you've kind of broken down the idea of expected value before. I know I had you in 98. We did something similar to this, but we used scratch-it tickets and dice games, and they were a little bit more straightforward because I didn't have you calculate the probability. I just gave them to you. I gave you a spreadsheet to look at. I can see why that's kind of throwing you for a loop. I bet you the expected value part you remember at least a little bit from Math 98, but I bet you the calculation of those probabilities is a little bit tricky. Okay, I hope that helps, dear friend. Sorry, I'm just getting it now. I'm going to get this video on YouTube for you and send it to you. Talk to you soon. Be well.